as we're going through. All right, what is the solution to this system of equations? So what point is the solution? All right. If my screen is taking up the whole screen and you're playing on your computer as well, then press escape to get my screen out of full screen, and then you can make it smaller and put your screen on there as well. Okay, or just yeah, that'd be the easiest way. Or like I've got the computer up, and then I actually have a phone that I can use, so I'm playing as a player on that. All right, so we got two lines intersecting, right? It's a system of equations because there's more than just one equation. So it's a system, and it says, where's the solution? Well, we go 1, 2, 3 to the right, comma 2 up, right? So 3, comma 2 is the coordinate pair for that answer. All right, let's try the next. All right, what is the solution to the system of equations on this one? Alrighty. So we've got two lines intersecting again, 2 to the left and down 1. So left is the negative direction, right? So -2, comma -1. Right. Emmett, if you're just joining us, then look for the game code at the bottom, and you can join our game here. All right. You need a little more time. So here's our image. We got two lines that are intersecting. To find that intersection, we find where they are touching each other, right? So we've got 2 to the left, because we go left and right first, and then up and down. So -2, +1, 2, 3. So -2, comma 3. -2, comma 3. It is. Okay. All right. You guys are good. I'm just checking to see. Okay. Making sure we're all okay. All right. Next question. What is the solution of this system of equations? So we got two lines, and it looks like they don't touch. So what would our solution be? Alrighty. So if we have two lines in our system of equations and they never touch, they're parallel, which it looks like these are, let's see, rise 1, 2, 3 over 2, rise 1, 2, 3 over 2. Okay, they have the same slope. So they are parallel, means they'll never touch. So there's no solution. There's no point that works for this line that works for this line as well. All right, so no solution. All right, what is the solution of this system of equations? What do you guys think? Okay, so we said green and yellow. Okay. So just be careful. We go left and right first, and then up and down, which is different than saying like what's the slope of something, which would you guys would be right then, which would be like rise over run, rise over run. But as far as just finding a coordinate spot of labeling it, we could say, okay, this is at a certain spot, and we have to go start at the origin and go right as many or left or right and left, and then up and down. So we had to go 4 to the right, down 1. So that's why it's 4, -1. Sorry. That's why it's 4, -1. All right. Next question. Good job, guys. Nice. All right. Graph these lines. What is the solution? So once again, if we have these two lines and we graph them, what would our solution be on this? So it's asking the same sort of thing. Where's the solution? Alrighty. Good job. So -2, -1, that's our solution. Because it works for the blue line and it works for the red line. Good job. All right. What is the solution on this one? Let's see who can get it first. Good job, guys. So 1, 3, that's going to be our solution to the red line and to the green line. Excellent work. All right. Last two. So where's the solution on this one? All right, let's check on this one. So I think that is a mess up, because this should actually be 2 to the left and then up and down none, right? So it should be -2, 0. So you guys all got that right. If you put green, that is correct. All right, so sorry about that. I'll have to edit that, but it should be -2, 0. Good job. All right. And the last one. What is the solution to this? All right, good job. And actually, I wish there was one more. But if there was 2 lines right on top of each other, okay, so like if you graphed one equation and you graphed another equation and you realized, oh, that's the same line. If they're both on top of each other, then the answer would be infinite solutions on that type of problem. Okay, so infinite solutions for that type. All right. Good job, guys. Good, and just looking at our scores, kind of more than the points. Excellent job. And it's just gonna be there. All right. right, good job, guys. Very, very good. Nice little refresher there. You guys all did great. And so what we're going to do today, we are just going to do a couple other, basically we're going to do a couple other problems together. And then we are going to kind of make sure we're all understanding the material and all doing well in this as well. All right, so let's see real quick. What I want you guys to do right now is, if you don't already have a copy pulled up of this file that's in the chat now, go ahead and head to that link and do File, Make a Copy, so you can follow along with me. Okay, and then okay. So the first thing I want to do, us to do together is, before we actually head to the slideshow, I want to see if we're doing okay as far as the IXL practice that we were assigned from Tuesday. So I'm going to share my screen with you guys. Okay, so it was AA2. So that means if you're in math and then you go to 8th grade, right? And then AA2 to 80 SMART score. That was our objective or our goal. And you know, if you haven't finished it yet, I encourage you to get that caught up. That way when I put that grade in, you get a good grade on it. So this is solve the system of equations by graphing. First graph the equations and then type the solution. Okay, so it says click to select points on the graph. And so I'll make this bigger. There we go. So on this one, I'm going to click for whichever dots I'm drawing. So let's say I'm doing the y equals x minus 1. Okay, y equals x minus 1 would be a slope of 1, right? And then a y-intercept of -1. So I would say, okay, y-intercept's at -1. And then my slope is 1, or 1 over 1. So that means 1 over 1 would be rise 1, run 1. Rise 1, run 1. Rise 1, run 1. Okay, so it would look like that. Then I click on the yellow line, y equals 2x minus 3, and I say, okay, -3 is my y-intercept, 2 is my slope. So I start here and I go, okay, down 1, 2, 3, -3, that's my y-intercept. I click there to place my point, and then I say my slope is 2, or if I wanted to write that as a quote-unquote fraction, I could say 2 over 1, which means rise 2, run 1. Rise 2, run 1. So I'll do that here. Rise 2, run 1. Rise 2, run 1. Rise 2, run 1. Like that. Okay, and then I press on any of those dots, and then I can see my graph. Okay, and I say, oh, my solution's right here, right where they touch. So that's going to be at the coordinate point 2 to the right and 1 up. So that's 2, 1. 2, 1. Submit. And we got it correct. Okay, so and at the end, if you need more help on this, I can help you a little bit more. But I just kind of wanted to show you how that works. You graph your 2 lines, and then you can use, it's like instead of using graph paper, which is nice and fun, but without graph paper, you can use this, and you'll graph your 2 lines, and then wherever they intersect, you can notice where that is, and that'll be your solution. Okay, so, alrighty. So, looking at our slideshow here, and let me minimize. All right. So solutions to the systems of equations. All right. So by now, you guys already know that the solution is the point where both equations meet, right? We just did a Kahoot on that. And by the end, you guys were all getting it right. Okay, so the solution is the point where all the equations meet. And it says both, but there could be more than 2 lines. For this grade and I think 9th grade, you'll just have 2 lines. Okay. All right. So then it says we also need to determine if a given point is a solution to the system. So if we're given this and it says 2, 5, is that the solution to this system? Maybe it's a word problem. Maybe it's, I don't know, $2 cash for every 5 people that bought lemonade or something at a lemonade stand. I don't know. We don't know the context. But we say, okay, 2, 5, we think that's solution. And then how can we check, guys? This is where I want you guys to respond. Be ready in the chat because I'm going to keep calling on you guys. But in the chat, I want you guys to just shoot a message real quick. What do we do to check and see if 2, 5 is a solution to both of these equations? What do you guys think? Okay, I got graph it. Another graph it. Okay. Oops. Okay. So you're saying we could graph both of these and then see if they both intersect at 2, 5. We could do that. That's true. Now, they didn't show us a picture or anything, so we would have to graph both of these and then check and see if it's the same one. We could do that, but if we are given a point like this, we can also just substitute our values in. Okay, so if I am doing this problem, I say I could graph it, but it might take a little while. But I know that this is the x that I think is right, and this is the y that I think is right. So let's check. I can plug in my x is 2, right, and my y is 5. So then I substitute those into these 2 equations. Okay, so I say, all right, y equals 2x plus 1, so 5 equals 2, and then instead of x, 2 plus 1. And then y equals 3x minus 1. So y equals 3x, which is 2, minus 1. All right, and then all I have to do now is just check and see if that works out. So 2 times 2 is 4, okay, and then 4 plus 1 is obviously 5. So then I have the answer 5 equals 5. Is that a true statement? Yeah, right? 5 equals 5. So that one works. Alrighty, and then 3 times 2 is 6, minus 1 is 5. 5 equals 5 again. Okay, still true. If it's true up there, it's true down here. So if both those are correct, this is the solution. Okay, so we said, is this the solution? And we just confirmed, yes, it is. Okay, and as we said the other day, if it did not work for one of these 2 equations, like let's say it worked for the first one, and then we plug in our values for the second one, and it comes out to be like 6 equals 4, that's not true, right? So then that would bust our system. We would say, oh, it doesn't work. All right, so practice, a quick check. I want you guys to do the same thing on your own. I want you guys to take this coordinate pair and check to see if it's a solution to this system of equations over here. Okay, so take about a minute and a half, plug in your coordinate pair, substitute it in, and see if it is a solution. And then you can slide your circle in your own slideshow to either yes or no. So go ahead and do that. Your screen for a sec. All right. If you think you got your answer, just type in a quick done in the chat. Okay, that is fine. Yep, take your time, guys. If you need some extra time, go ahead and take that. All right, we'll say about 15 more seconds, guys, and then we'll go ahead and check it together. All right, awesome. See what they get, and see what we get together, and we'll be able to check it. Good job. All right. So if you're still finishing, that's okay. You can continue to finish up. Otherwise, go ahead and check and follow along with us. So let's see, we've got 1 comma negative 2. And if this is, it says, is this point a solution to the system? So we're going to go check and see if it is. So we say, okay, our x is 1, right? And that means our y is a negative 2. So if x is 1, y is negative 2. Then we plug in our values. We say, okay, this first equation says y equals 3x minus 5. So y is actually a negative 2 now. And x is a 1. So 1 there. Okay, and then same thing down here. Y is a negative 2. X is 1. And now we multiply and solve now that we substituted those numbers in. So 3 times 1 is 3, minus 5 is then negative 2, right? So this bottom equation now says negative 2 on the right-hand side, and then it's just a negative 2 on the left-hand side. So is that a true statement? What do you guys think? Okay, it is going to be a true statement, right? Negative 2 is equal to negative 2. Yeah, that makes sense. So then we look at the second one. Negative 6 times 1 is negative 6 plus 4. So you're at negative 6 and you go 4 towards 0. So you're at negative 2. Okay, I can already tell this is going to be negative 2 equals negative 2, right? So this one worked as well. Oops. Yeah, so this one worked as well. So we've got this coordinate pair worked for this solution, this equation and this equation. So is the point a solution to the system? Yes, it is. Okay, so if you got yes, that is the correct answer. Okay. All right, so yes should be the correct answer on that one. Okay. I want you guys to go ahead and try one more time. I want you guys to get a head start on this, and then we'll solve it together. Okay, it'll be a little less time on this one, but I want you guys to see if you guys can get this, okay? So is this point right here that I'm circling, is this a solution to this equation and this equation? Okay, so I'm going to give you guys 1 minute to get a head start. Plug in those values, the negative 2 and the 12, and see if you get 2 true statements. Okay, ready, go. Okay, about 30 more seconds. You guys are doing great. All right. Hopefully you got a good enough head start. And I'll just move kind of slowly and see if we get the same answer. Okay. And then at the end, I'll ask you if you got the same. Well, actually, I can ask you now if you guys got if some of you guys got done. Are you guys thinking it's gonna be the solution to the system or not a solution to the system? What do you guys think? Either with your mic or a chat, go ahead and say, do you think -2, 12, is that going to be a solution to the system? Yes or no? What do you think? Okay, I've got a no. Good. What about Emmett? Edna, what do you guys think? What do you think, Emmett, Edna? You think no as well? Okay. All right. Well, let's go ahead and check and find out. So x is -2, or at least supposedly, right? Y is 12. So x is -2, y is 12. So it says, is this point a solution to the system? Well, let's check it out. We substitute those values in. So anytime I see an x up there, I'm going to plug in my numbers. -2, -2. Both of my y's are 12, of course. And so let's see. 8 times -2 is going to be -16. Okay, plus 4 is going to be -14, right? So now we have 12 equals negative, or not 14, -12, right? And then on this one, we've got negative times a negative is a positive, so that's 2. And then -10 is going to be -8, right? So this one says 12 equals -8, and actually this one looks like it was going to be right, but it says 12 is equal to -12. Okay, so this one did not work. Okay, it's hard to see. Okay, this one didn't work, right? And this one didn't work either. So it looks like this point is not a solution to this system. In fact, it's not on either of the lines. Otherwise, one of these would work. So this is just some other point out in space. All right, so the answer, no, it's not a solution. Okay, so that's how you can check if your answer is correct on a system of equations, whether you are given the point or if you found the point and you want to check and make sure you got it right. You can plug it in or substitute it in like we did here. All right, so stay with me, guys. We're going to run through this real quick. Finding the solution, it's going to obviously be where the two lines intersect. In this case, it would be this green point, right? Which happens to be at 2, 5, right? So that's why that solution's there. Okay. We're going to do just one of these real quick. Well, okay, we'll see how fast we can do. So let's graph one together. Okay, so you guys have movable pieces on yours. And and I actually have it on my other slides, but I kind of want to draw. So we're going to graph these two equations and see what the solution is to the system. And so what I want you guys to do is use your red dot for your y-intercept and then blue for all your other dots. Okay, and then use your lines and put the green dot on the answer. So for this one, what is our slope and what is our y-intercept for this first equation here, guys? Well, you guys go ahead and answer that. What is our slope and our y-intercept for this first one? Go ahead and answer in the chat. What part of that equation is the slope? What part of that is the y-intercept? Okay. You guys are still thinking. So don't forget y equals mx plus b, okay? That's slope-intercept form of a linear equation. Right, so that means that the slope would come right in front of the x always, and the y-intercept would come at the end, right? Eleni, so you said the slope you think is 2 and y-intercept is -2. That is correct. Good job. Yep, so slope comes in front of the x, and the y-intercept always comes at the end. So let's see, our y-intercept is -2. So I can already take my red dot and place it at -2. Okay, and since I already, yeah, okay, and so then now I know my slope is 2, which I can rewrite as 2 over 1, right? Isn't that the same thing as 2? The reason I write it like that is so I can do the whole rise over run thing. So I can visualize what's going on. So I say, oh, okay, it's going to go up 2 for every 1 to the right. So I go up 2, right 1, and let me change this. Okay. Up 2, right 1, place a point. Up 2, right 1, up 2, right 1. Okay, like so. So that's one of my lines, and then I would okay. Sorry, make that a little bit thinner. Okay, so that's my first line there, and then so then I do my second line. Y equals -2x plus 6. So my y-intercept is going to be at +6. So I go up 6, place my y-intercept, and that's where I'm going to start, right? I don't start at the origin. I start at my y-intercept. And then my slope on that one is going to be -2 over 1, right? It's a -2. So that tells me that the rise, quote unquote rise, is going to be down 2, and then it's a +1, so right 1. So I go down 2, right 1, down 2, right 1, down 2, right 1. Okay, and so then I have my second line, and now I connect my dots like so. And where else do they hit? But right here. So that's at 2, 2, looks like is the solution. So I would say my solution is 2, comma 2. Okay, and I could put my green dot there if I needed to. Alrighty, so I want you guys to go ahead and do this, this next one by yourself, and then we're going to check it, and then we're going to do one last thing real quick before we go here. Okay, so go ahead. Once again, I want you to work ahead. See if you can graph it, find your intersection. Remember that your slope is always going to come right here. Oops. If it's slope-intercept form, it's going to be y equals mx plus b, where m is your slope and b is your y-intercept. Okay, so go ahead and get started and give that a whack. All right. And it's getting closer. Okay, we'll say about 1 more minute to make sure we have enough time here. Okay, once again, guys, if you are still finishing, that is A-okay. Does anybody want to share what they got for their answer if you did get finished? All right, so let's go ahead again. If you're not quite done, that's okay. Just make sure that you are checking with what we got and what we're getting to make sure you got it right. Okay, because that's our whole goal, is just to make sure that we're understanding and we're learning. All right, so this last one we had y equals 2x minus 4. So that means our y-intercept at -4, right? So we can place our dot at -4. And our slope is 2. Okay. 2 is the same as 2 over 1. I can put a 1 under it. And that allows me to do rise over run. Awesome. And to be honest, Eleni, I haven't checked this one yet myself. So let's see if you got it right. So rise over run, 2, that means up 2 and right 1, if these are both positives, right? So I do that on my screen, up 2, right 1, place, up 2, right 1, up 2, right 1, 2, right 1. Okay, that's my first line, right? So then I graph that line. Oh no. Let's try that again. Okay, that's pretty close. So then that was my first line, and now I do my second line. It starts at a positive 6, so I go up 6 and place my y-intercept. That's where I start. And then from there, from that point, I do my slope, which is a -3 on this one. Okay. Just like my other one, I'm going to put it over 1. And so now, real quick, guys, if this was like 3/4, okay, if our slope was 3/4, then we wouldn't have to put it over 1, right? We'd already have, like, again, imagine this -3 as a 3/4. Then we would already have a rise over run, okay? We'd already have a fraction. So we wouldn't have to do anything else on that one. But on this one, we had to put it over 1 to make it a fraction, to where we can say rise over run, right? So rise over run for this one is down 3 instead of up, right? This is the negative. So down 3, right 1. Down 3, right 1. So I take my point and I go down 1, 2, 3, right 1. Down 1, 2, 3, right 1. Down 1, 2, 3, right 1. Okay, 1, 2, 3, right 1. And then I connect them with a line. Let's see what I got. Right there to there. And again, this line really goes on forever, right? So they should just keep going forever with arrows. All right, so it looks like our solution is right, and it's not perfectly able to be seen, but it's right here, okay? So it's at 2 to the right, looks like, right? And not up or down any, it's on the axis, right? So our answer is gonna be 2, 0, because it's 2 to the right and 0 up or down. Okay, so quite close there, Eleni. Good job there. Pretty close. And then, so on this though, looks like it's going to be at 2, 0, okay, guys? So hopefully you were able to follow along on that and see how we graphed those two lines and where it met. Okay, and you can always rewatch this video if you need to later. Okay, all right, so the last thing I just wanted to point to you guys is either if you don't have science next, if you do have science next, I don't want you to feel rushed into starting your next class. But if you don't have science next, or if you want to do this a little bit before then, I just want you guys to hop back to the Desmos activity we were doing the other day. Okay, so I showed you guys this, and so it shows, you guys did several of them. I asked you guys to do the first 6, okay? Looks like Caleb did his, and you guys did several of yours. Excuse me. But I'd really like for you guys to try to do, I wanted you guys to do this first 6, and today I want to actually make sure that you guys get to 7, okay? That way you get a few of each type of problem. And if you want to go ahead and do the other ones, you can. This is just some more practice. But the IXL is already going to kind of test you on these types of problems, okay? So your assignment for today, guys, is if you're not done, okay, if your picture here doesn't show you that you did all of them, make sure you do 1 through 7 on this Desmos. And then I want you to make sure that you have your IXL AA2 to 80.